Now, critical path method, CPM. After the construction of a project network, its time analysis becomes essential for planning various activities of the project. The duration of individual activities may be uniquely determined in case of CPM or may involve three estimates in case of PERT. So whenever the definite time is given, we can use the CPM, and indefinite, that is not definite time is given, we can go for the PERT. That is, you have to estimate the time duration for PERT. So the planning schedule should include the following factors. One is total completion time for the project. That means in how many days or how many weeks, in how many months the total projects will be to be completed. So in the previous lesson, we studied how to draw the project network, that is network diagram. Now we are assigning the time, in how many days the total work to be completed, that one we are studying. Earliest time when each activity can start. What is the earliest time when each activity can start? And the latest time when each activity can be started without delaying the total projects. So without delaying the projects, on how many, what is the latest time when each activity can be started without delaying the projects, total projects time. So to float for each activity, that means without delaying a particular, without delaying the total project's completion time. So particular activity, how many days we can delay. So that one, that is called the float. So identification of critical activities and critical path. So identify what are the various activities which are critical and what is the critical path. Means that is that path you should not disturb. If you disturb the critical path, the total project completion time changes. Forward pass computation for earliest event time. The forward pass is computation is used for the earliest event time. Okay. First, what you have to do after, in this method, calculations begin from the initial event. First, from the starting event. In the problem, I'll explain in detail. Just I'm explaining here the method. So from the beginning, that is from the beginning of the initial event, set the earliest occurrence time of initial event as 0. That is 0. The time event time is denoted by TE or EI. That is TE is equal to 0. We can write instead of EI. If you want, you can use EI also. The earliest starting time for activity I comma J. IJ means does tail. The arrow is there now, arrow. The tail is called I and the head is called the J, IJ. This is the earliest event of all the tail and end event of ESIJ is equal to EI, or you can write T. Now, the earliest finish time of activity IJ is the earliest starting time plus activity duration, that is called EF, earliest finish time. Earliest finish is nothing but earliest start time. ES you can write plus DIJ, that is the duration of activity. Or earliest finish time you can write in other words, EI is equal to DIJ. Anyway, the earliest event for event J is maximum of all the earliest finish times of all activities ending that event. That is EJ is maximum, EF, IJ for all immediate predecessor of IJ, or EJ is maximum for EI plus DIJ. In the problem, in illustration, I'll explain in detail. So now you cannot understand. So backward pass computation. This is for latest allowable time. So in this method, calculations begin from the final event. So forward pass method from the beginning event. So the backward pass method, which will start from the final event. That is the difference. For entering the event, assume E is equal to L. Remember that all ES have been computed by forward computation. So we'll get the from the forward pass computation method, we'll get some values, earliest time values. So okay. So from that we are calculating that latest allowable times. The latest finish time for activity ij is equal to the latest event time of event j. Okay, that is j. The latest starting time activity I comma j is the latest completion time of I comma j minus the activity time, that is called the duration. Or we can say LSIJ is equals to LFIJ minus DIJ, or LSIJ is LJ minus DIJ. The latest event time for event I is the minimum of the latest start time of all activities originating from an event. That is, Li is minimum of Lj minus Dij. Now, computation of floats and slack time. See here there are three floats: total float, free float, and independent float. These we are talking about. Total float of an activity is defined as the difference between the latest finish time and the earliest finish of all activities, or the difference between the latest start time and the earliest start time of activity. That is, it is denoted by TF is equal to TFIJ is equal to LSIJ minus ESIJ. So, or TF is equal to LFIJ minus EFIJ. This is the most important time of float because it concerns the overall project duration. Total float. Total float of an activity is the amount of time by which the particular activity may be delayed without affecting the duration of the project. Okay, this is about total float. Now, free float. What is free float? Free float of an activity is a portion of the total float which can be used for rescheduling that activity without affecting the succeeding activity. That it is denoted by FF free float is equal to Fij is equal to total float of Ij minus of TL minus TE of the event, or you can where TL is equal to latest occurrence time, T is the earliest occurrence time. Next one is independent float, IF, of an activity is the amount of time by which an activity can be rescheduled without affecting the preceding or succeeding activities of that activity. So independent activity is equal to IFJ. IF is equal to IFIJ is equal to free float of IJ minus TL minus TE of the event I. The negative value of independent float is considered as 0.